Let's go to another. Let me go on down and I'll find another geometry question or probability question. This number 7 is another one that's a really good problem that people tend to have trouble with. Because it's not, you don't really want to solve it. What you're trying to do is use properties of commutativity and associativity and distribution to answer the question. All the following are the equivalent of dividing 288 by 24. So you're starting with 288 divided by 24, right? So you have to ask yourself, use little numbers. Like if you did 20, let's do 24 divided by 6. All right? Would that give you the same thing as 24, this is two numbers, 24 divided by 3 and divided again by 2? I mean, can you break the 6 up? Does that work? If you divide by 3 and then 2 again, do you get the right answer?
Yeah.
Yeah, 24 divided by 6 should be what? 4, yes. And if you take 24 and divide by 3, what do you get? You get 8. Divide by 2 again, you get 4. So, yeah, you can divide your 10s. This goes back to base 10. You can divide, well, this isn't a 10. This is a factor. But you can divide in pieces, just like you can multiply in pieces. Like if you multiplied 6 times 8, you could multiply 6 times 2 times 4, right? It's about association, it's about breaking it up. So that's kind of the properties you're looking at here. So the question is, if you have 288 divided by 24, well, what are factors of 24? That would be 6 and 4. So here you're saying 288 divided by 4 and then divided by 6 again, right? Those are factors. So yeah, that would work. That's probably the right answer. But that would work, all right? Does that make sense what I'm doing?
Yes.
So we broke 24 into factors, and we just showed that if you break it into factors, you can divide each factor out separately, which is what you do when you reduce fractions. Like a lot of times you'll divide by 2, and then you look at your answer and say, oh, I can divide by 2 again. Well, you've just divided by 4. Yeah. You just did it in 2 different pieces. It's the same property. This is 2 times. Now this isn't going to work because you would do 144. Let's see, 144 divided by 24 is going to be. This is 144 divided by 12 is 12, so 24 is going to be 6. So we have 2 times 6, and that's going to give us 12. Let's see, 288 divided by, I don't know if that's the same, 12. If this is true, then 12 times 24 should give us, what is 288 divided by 24? You guys remember a long division? I don't have a calculator, so we'll just cheat and do it this way. Okay, that's 1 with a remainder of 4. 24 goes into 48, so it is 12. Okay. All of the following. Oh, I thought you were looking at the one that wasn't right. I'm thinking, but there's 2 already that work. Okay, so that one works. Okay, so what this tells you is that multiplication is the reverse of division, right? 6 divided by 4, 24 divided by 4 is 6 because 4 times 6 is 24. All right, so 288 divided by 24 could also be 144 divided by 24 multiplied by 2. You're multiplying it back up. So you kind of have to play number games in your head. 144 divided by 12, 144 divided by 12. Does that work? No, it does not work. Exactly.
Isn't 144 divided by 12, 12? I don't know. Is it? I don't know. But it's in. All you had to do really was do the division and add it together, and it was
exactly. Yeah, this is going to be 12 plus 12.
Yeah.
Right.
That's what I was saying.
Right.
Yeah.
You're exactly right. The reason this doesn't work is because up until now we've been looking at factors, things that multiply together. 12 and 12. This is not a factor. Now, if this was a factor of 24, like 6 and 4, then it would work. You see what I'm saying? So the sums and factors are different, and that's pretty much what they're getting at. They're taking 240 and then 48, and once again you're dividing by 24, which is a factor of itself. So this is the whole idea of factors and multiplication, division work. Add-ins don't. When you have 2 things that add together, it's not going to work. You can't add to 24 when you're dealing with multiplication, division. You can only multiply to 24. You see the point?
Yeah.
So be careful of that when you're working with multiplication and division. If they're giving you sums like 20 and 4, it's not going to work because that's a sum and that's not a division. I just wanted to point out the property because they ask all kinds of contortions on problems like that.
So like if
Go
I
ahead.
was doing it and I'm like pressed for time, couldn't I just do 2288 by 24 and get the answer and just see which one don't add equal?
You could. You have a calculator to do
Yeah,
this.
that's
Yeah,
what I'm saying.
yeah, you could. Some of the ones I've seen they will use X in place of it,
Yeah.
and that's where you run
Yeah,
into
yeah.
trouble. Like
Yeah.
if they have 288 divided by 2 times some A, then 2 and A are the factors, so every one of these have to be a 2 or an A. And if they had a 2 and, well, let's say I'm trying to think of something they could do that as sum. Here, let's say they had 288 divided by 6A, right? Any combination of 6, which would be 3A and 2, which makes 6A, right? But the one thing you couldn't do is 288 divided by 5, A, and 288 divided by A. Because A and 5A add to 6, they don't factor to 6. So that was kind of what I was getting at. So that's a huge thing that keeps coming up as far as what are the properties of multiplication and division. Okay, let's go on and find some more geometry problems. I just wanted to point that out because that problem I've seen come up more than more.
Is this for like the first Praxis or is it the elementary math Praxis, second one?
This is actually the second one that I'm looking at, but it's got everything on the first one plus.
Okay.
So if you can do this one, you should be pretty comfortable. It's just the strategies you go through to finding them. Which of the following could be the product of two even numbers? You guys know whenever you're testing, you always test negatives, positives, and fractions. You know that?
When we're testing?
Yeah, like for instance, which is, well, this is not specifically that, but they might ask you, I'm trying to find one here, where they would say something like, oh, here you go, here's number 14. Number 14, which of the following is true for all values of A? A plus A, this actually kind of goes right after what we talked about a minute ago. A plus A divided by A plus A is 0. Is that true? Which property is this? This is actually the inverse, it kind of rolls off the inverse product. You're not going to get 0 with division or multiplication. You get 0 with addition and subtraction. If this were 1, that would work and that would be true. A divided by A divided by A is equal to 1. So here we've got 1 already, right? So if you divide by A, there's no way you can get another 1 out of it. Well, yeah. No, you can't. You're going to get 1 over A. See how that works? A divided by A is 1. Now you're dividing by A again. That's going to be 1 over A. That's not going to be 1. Okay? Does that make sense?
Yeah. Not really.
Okay. Well, anything, no, that's fine. That's fine. I'm asking. Okay, so anything you divide by itself, it doesn't matter what it is. It can be 1,000 divided by 1,000. It can be x squared over x squared. Whatever it is, when you divide it by itself, you're going to get 1.
Right.
So you've already gotten 1 when you divide it here. So now you're taking 1 and dividing by A. That's going to give you 1 over A,
right.
not 1. Yeah, because you're dividing by A.
Yeah, they would have to have a 1 in there, wouldn't it? So like A divided by A is 1.
Yeah.
So then 1 divided by A, that 1 doesn't have an A, so you can't divide. They're not like, so you can't divide them. So
Exactly.
Okay.
This is a plus. Oh, this is still fine though. So this is going to be A plus A is 2A, right? Divided by A plus A, which is 2A. There you have two things divided by themselves, and that gives you 1, not 0. This is multiplying and then subtracting exactly the same thing. Does that give you 1? It gives you 0 because here you're using the additive inverse property. You see what I'm saying? So you can't mix multiplication and division with addition and subtraction. You need to pay attention to the properties. If you're subtracting or adding, you're going to be getting 0. If you're multiplying or dividing, you should be getting 1. So by default, this has to be A minus A is going to be 0, times A is 0. That's the only one that works. So they're mixing their properties together, trying to catch you making a mistake. Okay, do you guys know which property this is? 15 times 5 plus 4?
The distributive.
Yes. And this is a big, they will give you something like this and they will say, is this the distribution property? And people, what is that? Is that distribution property?
No, that is, is it distributed?
How do you know if you've got the distributed property? What
Because, no, because you have to have another variable, right? If, you know,
There's one big, huge problem with this not being distribution.
it's not an addition.
Yes, distribution is multiplication over addition.
Yeah.
This, something like this would maybe lead to the associative property, where you could do 15 times 4 associated together. You guys know associative property, you think it clicks? Two people associate with each other and then they get mad and they associate with the other two and then they ignore the third person. That's an easier way to remember, you know, you just, I have a bunch of those advanced STEM high school kids and I said, give me an example of something that helps you to remember. Well, you know, because we had A and B. Well, A and B are sharing lunch and then C they don't like, but then B steals all the money from A, so A decides he's going to go be friends with C. You know, which is, I thought it was pretty funny, so it's stuck in their head. But that's the associative. So distribution doesn't happen unless you have a multiplication and addition. You have to have both operations. It's the only one that goes over both operations. Okay. Oh, I thought that was a circle. Let's see. Oh, this is a circle. Good. I thought I saw the circle. So this is a geometry problem with circles. What'd you say?
But the circles are the worst room.
Okay. Well, let's go ahead and go back to the smart board. And let's look at what we know for a fact about circles. Because again, you've got to list your properties of circles. What do you know about circles? We have some very specific.
360.
Okay, so the what?
Don't they all equal 360?
Yeah, the angle measure all the way around the circle is the total sum of the angles. Total angle measure is the 360. Okay, so that means half is 180, right?
Right.
Okay. What do you know about the circumference?
This circumference equals, is it something times the radius times the circumference equals pi? I don't know.
It's either 2 r's times pi or d times pi, because the radius doubled is the same as one diameter. And the diameter, by the way, has to go through the center of the circle. If it doesn't go through the center, it's not a diameter. So this whole thing is a diameter, and each of these halves of the diameter is a radius. And it doesn't matter which one you use, all right, unless you specifically have to find. For the circumference, it doesn't matter. Use whichever one you have, whichever one you like. Now, for the area, what's the area formula? What did I spell there? Oh, that's a C. Okay, I thought that was a. That's weird. Okay. So the area of a circle, what's the area of a circle?
Isn't it radius times pi?
It does have a radius and it has a pi. It's actually pi r squared. Yeah, you're squaring. Remember, squared means you multiply by itself. If you guys do calculus, this is really easy to remember. Because it's okay. I'm going to go to general area and length. Let's go back to squares to explain this. Okay, when you talk about perimeter, you're talking about distance, right? And when you're talking about distance, you're talking about length, which is a single dimension, right? See what I'm saying? It's a single dimension. You know, this would be like 6 feet. Let's say this is 2 feet, all right? So when you travel in distance, you're traveling just linearly. There's only one dimension. When you talk about area, you're talking about 2 dimensions. All right? So in area, your answer is going to involve length. You know, if you're talking about the square, it involves length and width. And your unit is going to be squared. Because you have to, whoops, what happened there? Oopsie. Let me see if I can, oh, there we go. I don't know how that happened, but, oops. Okay. Okay, so your unit ends up being squared, right? So whenever you write length, your perimeter is gonna be, in this case, it'd be 6, and you don't need to remember, just count, walk around this thing, you know, because sometimes they'll give you these oddball shapes that look like that, and you just have to follow the whole thing around, all right? So, you have 2 feet plus 6 feet is 8 feet plus 2 feet plus 6 feet is 8 feet again, so you have 16 feet. Okay? When you're looking, and this is a question I see, when you're talking about area, you're talking, the reason it's squared is because you're literally counting how many squares are filling this up. That's literally why area is squared. So how many squares do you have in there? Well, you have 6 squares by 2 squares, which gives you a total of 12 squares, which is where your length times width area formula comes from.
That makes it so much easier when you explain it like
You
that.
just count the squares. And they may give you, I don't know if they've ever given you any pictures where they have squares, literally squares, and that's what the area is. I don't know if they go into
They
that.
give me, I remember it was like this brick house thing or something, but it was like so uneven and then.
Yeah, and I'll do one like that in a minute, right.
Okay.
But area is squared because it's literally squares. I mean, you could have our units could be in triangles, but that, how do you fill up, you know, triangles are awkward. Squares are nice and neat until you put them in a circle, which is why the circle formula looks different, is because you can't fill a circle up with squares. Because, well, you actually are filling it up with squares, but it's hard to count them because they're going to be like leaking over the edge, right? They don't make nice, pretty units, whereas squares and rectangles do. So we have 6 squares by 2 squares, which gives you 12 squares. So your area, and this is something I see all the time in the questions, they'll say give you multiple choices, and you don't even need to know the number, you just need to know the unit. Whatever this is, it doesn't matter what this is. This ends up being 12, but this is what you're looking for is feet squared. That square runs the whole program. It doesn't matter what the number is. If it's not ended with a square, it's not an area. It can't be an area.
So area always has to end with a
Area is
square.
always squared because that's how we measure area, is how many squares you have. So that's always the answer.
Area always has a square.
So what do you think if you're measuring cubes, like if you're measuring volume, guess what your
3.
yeah, it's going to be cube. You're literally measuring how many little cubes are in this cube. There's 1 cube, right? So if it goes back 6, that means you've got 6 cubes. Let me make it small. Let's do 4. Actually, let me do it. Then here we'll have 1 more room. Okay, so I'll go back up there in a minute. So you've got this cube, right? So when you're asked to find the volume, the formula, let's say you have a 2 here, that means you've got 2 this way, and let's say this is 2. So we have 2 this way, and then we'll call this 4. So we have 1, 2. All right, so you're going to have 4 this way as well, right? So what you have here is you have a little cube, right? I'm afraid if I draw this, I'm going to mess it up. So there's that. Oh, here it is, and here's another cube, right? This is 2. Yeah, you have to draw that. So here's a cube right here. Here's a cube right here, right? There's a side of the cube, top of the cube, side of the cube. You've got another cube back here. Here's top and side. You've got a cube in here that you know, here's a cube right here, right? You see what I'm doing? So you're actually counting cubes. That's why all volume ends with cubic measurements. So you have in volume, you've got 2 times 2, because you have 3 dimensions now. So it becomes 2 times 2 times 4, which gives you 16. And if these were feet, it would be now cubed. So it doesn't matter what the number is, it has to be in cubic units or it's not volume. And that's true of water or anything. I mean, it doesn't have to be a square. If you've got a sphere, which is a 3-dimensional object, and you want to know the volume, it has to end in a cube. Okay, it has to end in a cube. So they'll do liters and centimeters sometimes. It doesn't matter. If it ends in a cube and it's asking about volume, that's the answer. If it asks for area and ends in a square, that's the answer. You know what I'm saying? And plus you have to remember your different units of measurement. Like for instance, if you're dealing with volume, you should be talking about liters, ounces, something like that. If you're talking about surface area, you're talking about feet, inches, something that's a length, you know, when you talk about surface area. So you have to combine your units, whether it's a single area or cube, with the whole concept of what would you measure this with? Would it make sense to measure surface area with liters? No, liters is something you fill something up with, you know. So you're going to use you're going to use common sense problem-solving skills. So you don't even have to know what the number is, because by the unit alone, that's what they're asking. Really, is do you recognize what makes sense unit-wise? Okay, so back to our circle. I'm going to go ahead and erase this little cube, this foot example since it's on here. So the question is, what is the area? Because you asked, the reason that this came up, Destiny, is because you asked me about the area. So the one thing you can, whoops, what happened there? Oh, I have to go back to my smartboard. Okay, the one thing you can remember for the area is it's got to have a square on it. Okay, so that's a good way to remember. They both have pi in them. So circumference, when you're doing radius, you're talking about a length times pi. When you're doing area, you're talking about radius squared times pi. So if they give you the diameter, you cannot use diameter in area formula, but you can find the radius by doing that.
What can you add the two together to get 360?
The radius is half of the diameter.
Right.
So if they give you the diameter, you just take half of it and you got your radius. Yeah. So that's how you find it. So they have to give you something like that. And I'll show you the kind of questions I know they're going to put on there that have squares and circles involved. And that's where you have to find the radius based on the picture, or that doesn't give you the radius, which I'll do one like that. So these are the two key ones you need to know, is circumference and area. And you do have to memorize those two, and you have to recognize what you're looking at. So let me see if I can find a problem that actually does this. I think there's one on here where they actually do a circle and a square. If they don't, I can make these up pretty easy. There's lots of statistics on this practice one. But I'll make one up in a second. Yeah, I don't see any. So I'll go ahead and make one up. That's fine. So this is the kind of question they might ask you. I've seen this on every test. Something's usually similar like this. You've got a square, and then you've got, let's do a circle. You've got a circle and a square. All right? And they ask you, and then they've got the shaded region. All right, and they'll ask you to find the area of the shaded region. What is the area of the shaded region? And they can give you two different things. I'll do it in both ways, because what I'm doing is not examples of everything. I'm trying to show you the thinking process you go through, okay? Because you've got to identify what you know it's looking at you a lot of time, right there in the face, but you'd have to recognize that you're looking at it. And that's the key to these problems. They're not hard to do if you can find what you need from the picture. So they might tell you the square is a side, square side is 4, right? I'll give you that. So on your sheet, you're going to mark the side as 4. You have, and then they want to know the area of the shaded region. You have everything you need to know to find the area of all the shapes up there. So start by taking them apart. What's the area of the square?
16 feet squared.
Yeah, you've got 4 squares by 4 squares, right? So you've got 16. So the area of the square is 4 times 4, or 16. And this is going to be units. I'm just going to put units squared just so you remember this is all in square measurements, all right? And then what's the area of the circle? You actually have the information about the circle up there. You just have to identify it and connect it to what you know. Give me something you know about that circle. When you're talking about areas, you got to do radius and radius, diameter, something like that. Tell me, it's looking at you. You just got to identify it.
Wouldn't it be half?
You're on the right track, yeah. From here to here.
So if you put the diameter in there.
There you go. You know the diameter. Yeah, so you know the radius. The radius is what? 2.
Yeah.
And you know the area of the circle is what? What's the area of the circle? We just looked at it a minute ago. Pi r squared, which means you're going to take pi times 2 squared, which gives you what?
Would you still put pi, or leave times that by that?
Leave the pi as pi. If they tell you pi is 3.14, you can always do it at the very end. But usually they give you the answer in terms of pi. So this is going to be 4 pi. Traditionally in math, you put the number first and the pi second. Just to tell you, that will be the form that they'll do it. They'll put the number first. Does that make sense what I'm doing so far? Now, go back to the original question. What was the question?
What is the area of the shade?
Okay, use some common sense here. You know the area of the circle, you know the area of the square. What can you do? When I say common sense, I mean problem-solving sense.
Add it, both of them together, or do you multiply it?
Well, if you add both of them together, you're going to have this whole area and then the area of the square, which is much more than you need of this. So you want to just think of this as leftover. What is it leftover of?
Square.
It's leftover of the square after you've gotten rid of.
The circle.
Yeah, there you go.
So you take the circle away.
Which is what in math? You just said it. You said you would take away. Which take away? Subtraction, yeah. So you're going to take the square minus the circle, and that's going to give you what you want. Okay? So the square was 16. The circle, whoops, what am I doing? Equals, that's a minus. Was 4 pi, and that's going to be the answer. That's going to be looking at you. Okay? Literally. That's usually what your answer looks like on the Praxis.
So that's the answer?
That is the answer.
Wow.
A lot of times that will, and the problem is you can't work backwards on something like this if you don't know what you're looking at.
Yeah.
Okay? Now, if they told you pi is 3.14, I would still get to this point and don't plug in 3.14 till you have your final answer. But 9 times out of 10, they don't give you 3.14. They just tell you what's the answer.
A lot of times they, that was one of the questions, so it wasn't multiple choice, so you just answer what you answered.
Mm-hmm. This would be the best answer. Okay. This would give you the best points.
Yeah, because with pi, like calculators, they round differently.
Pi is an irrational number, which means it never repeats or stops. So anything you're doing is going to have an error because you're estimating by rounding. So that's why a lot of times pi is just left alone, because it's more accurate that way. Okay? Now, going back to just showing what else you could have given, you could have also been told, so here we were given the square, let's go ahead and start here. The square side is 4. You could have also been told the radius is equal to 3, okay? So tell me, let's just talk about what would you have done different if you were told the radius was equal to 3? How's that going to change? Not a whole lot, but how's that going to impact how you go about fixing it?
You got to go back to your area of the circle, like toward the 3 instead of the 2.
Well, first you have to put that information on your diagram.
Mm-hmm.
Where does the radius equal 3 going to go?
The diameter, right? Across the...
Right, okay, so, but that's not the radius, so the radius is 3, what is that line?
Well, that would just draw like a center point and a line to the side and put 3 on top.
Okay, so this is 3, which tells you...
The other side is 3.
Okay, so what do you know now about the circle? You know the radius. What do you know about the square?
The length is 6. The length of the sides are 6.
Yeah. Right? Yeah. So now you go and do exactly the same thing. Did you find the area of the square and you subtract the area of the circle?
Right.
But you're not going to be. You're going to be given everything you know you need. You just need to recognize that you've been given everything you need. Yeah. You have to be able to hunt down where that information is coming from. If that makes any sense. All right. So here's another one. The exact opposite. And this is, even though I'm doing the same types, this is good to get your thinking in the right direction. This is about what do I know? What can I take? You know. Take some time looking at it and think, okay, what do I know? What can I say for sure? So let's say I give you a circle. This is another one that you might get. And this is, well, this is a really terrible circle, but that's all right. Here, I'll try that one more time. There's a circle feature up here. But oh, here it is. Here, let's go and do that. Okay, so, whoa. Okay, so there's my circle. And then I'll go ahead and put a square, yeah. Whoops. That didn't work. Where's the pointer thingy? I may not be able to pull this off, but I figured I'd give it a try. There's a, oh, here it is, pointer thing. Okay, so let me see if I can grab this. Oh, wait. Oh, here we go. Okay, so let me go ahead and make this just a little bit bigger. Oops. Okay, that worked. Yay. Woo. Okay. So there's my, there's my, now I have a circle and a square inside a circle. So this one's a little trickier. I've seen ones like this. So let's say I tell you the radius is, we'll go something small, we'll say 3. You have to draw your radius in there in a way that gives you help. So tell me something about where's the radius gonna go?
Can you do it the same way, like just draw that line, the diameter across?
If you draw it across, you're gonna go across the circle outside of the square, which isn't gonna help you. You need to somehow connect the square to the circle. It's there, just look at it a minute. You want your radius to connect the square to the circle.
Is it at the top, like in this half of it?
Okay, so what do you, when you say at the top, what do you mean?
Like go through the center, like,
You do want to go through the center, but going this way won't help, because you're going to be crossing over, if you go straight up and down, you're going to be crossing over the edge of the square, which gives you nothing, because you don't know how much past the square you're going. The circle and the square make a single unit in a couple of spots. Where do they make a single unit?
Oh, you wanna draw it from center to where the corner?
Diagonal.
Yeah, diagonal.
There you go. Now you have a measurement of the square that's the same as a measurement of the circle.
oh yeah,
See how that works?
yeah.
And you know this is 3. Okay? All right, which means that this is 3, which means this entire half is going to be 6. Okay, for that. Now, again, if they asked you for the area of the shaded region, which is the red, you still have to, now, when you're done, you're going to have to subtract what from red? What?
You have the square from the
Circle, right. So you need to find the area of the circle and the area of the square. Again, it's just the order you subtract. So this is a little, right now you know the radius of the circle, right? So you've got this, the area of the circle you've got. Okay, the area of the circle is going to be what? What's the area of the circle?
Or pi squared.
It's pi r squared, which in this case is going to be pi times what?
Or
Yeah, 3 squared, which is, well, yeah, you're right, which is 9 pi. Right? 3 times 3 is 9? Okay, so there's the area. The harder part is going to be finding the area of the square, because right now you have a diagonal square, and the square needs side lengths. But you have just created what?
triangle.
Yeah, you just created a triangle, right triangle. Because squares have right angles, right? So you can use what you know about right triangles to find the side lengths, and what are you going to use? This is where you combine another property we talked about a little. Pythagorean theorem, exactly. So we'll call this S, and this is one of the things about squares. This wouldn't work for a rectangle, but we know the side lengths of the squares are the same. So we can use that to our advantage. So what you've got here is you've got side squared, right? So side squared equals h squared. So what is h squared? We don't know s squared, but we do know h squared. What is h squared? What's h? Yes. It's 9 squared, right? Because this is your hypotenuse. This is the triangle I'm looking at right here. Here's a side. Remember, the sides always come off the right angle, and opposite of the right angle is your hypotenuse. Okay, so this simplifies to what? What's s squared plus s squared give you? These are like terms? How many of them do you have?
So you have 4 inches, right? Or s to the 4th.
These are s squares.
Oh, 2s.
You have 2s squared. Yeah, exactly. Those are s squared. You know what I'm saying? They're their own unit. And you have 2 of them, which gives you 81, right? Let me put this down here. Equals 9 pi, and that way I can move down. All right, so you have 81, and then you can divide both sides by 2. I should have picked a... I'll just keep going. So we have s squared equals 81 over 2. They would give you like 2, the radius was 2, so that gave you 4, so when you square it, you had an even number, so when you divide it by 2, you would have a whole number. I guarantee you they would do that. They're not going to make you do this with a fraction. So that's going to, half of 80 is 40. I'm going to go ahead and write this as a decimal, just pretending like it's a whole number. Don't use decimals, but in this case, it's going to be easier to do, right? So that's 40.5 equals s squared, and then we did this before. How do you get s? We did this a little bit ago. How do you get rid of a square?
Square root.
Square root it.
Yeah.
Okay, so this becomes s equals the square root of 40.5. You see what I did there?
Mm-hmm.
That is your s. What was s? You have to remember what you're trying to find here. What was s?
The side.
Yeah, the side. So what I have now is that was the area of the circle, right?
Mm-hmm.
what I have now is the area of the square. This is the circle. This is the square. So now I know the area of the square is, what's the area of the square? You know S, which is your side. So you know this is the square root of 40.5, and this is the square root of 40.5. Yeah. So I'm going to multiply 40.5. What happens, and this is, actually, you know what, they might give you something like this, because this isn't that hard to work with. If you take something that's a square root and you multiply it by itself, what have you just done?
Cancel it out.
You've just squared a square root. Squaring a square root just leaves you with 40.5. Okay? So you know that A is there, circle's 9 pi. And what did you say, Destiny, what do you have to do to put these together? To find the area of the leftover, you're going to have to do what?
Take the square out of the circle.
Right, take the square out of the circle. So what does that look like? Here's my circle, here's my square. What does that look like?
40.5 minus 9 pi.
You're removing the square from the circle.
Yeah.
So you're going to
Oh,
take...
9 pi minus.
There you go. Yeah, exactly. Yeah, that's going to be 9 pi minus 40.5. Okay, and then that would give you the leftover. Okay, does that make sense?
Yeah.
Yeah. Those are just two examples, but this covered a ton of ground as far as manipulating and stuff like that. It makes a huge difference. Oh, well, here's another proportion problem, number 13. You guys see why that? Go ahead and look at read 13 and see. That is almost very similar to what we just did in the last two problems. Those are all, the last three problems have all been proportional, last two, and this is also proportional. Yeah, there's a way to go backwards, I guess.